parametric equations. I'll use this as an example to show you what I'm talking about. And we'll do it. Parametric equations are equations for x and y given in terms of another variable, which is called the parameter. And they usually use t, but sometimes they use theta. Usually it's t because you think of it as time, and x and y are changing over time, and so this gives how x is changing over time and how y is changing over time, and then you put them together and you can then see a relationship between x and y. Parametric equations. So I always used to give them and get them in a bracket form where they would give you x equals and y equals like that, because they always come in pairs. You have to have x and y. And it's just given in terms of t. 5t minus 1 and y equals t squared. Okay, and then a lot of times they'll give you an interval to focus on for t. In this case they do. For t in the interval from -4 to 2. If they don't give you a specific interval, then it's assumed that t could go -infinity to infinity, even though t is usually time. 0 on up is more common. But I would say otherwise, just for practical purposes, use -10 to 10. And then extend it as necessary if you don't see the whole thing. All right, so this one basically, again, x and y is given in terms of t. Let's do it on your calculator. You use parametric mode. So go back to your mode, and this time choose PAR. And then go to y equals, and you will see that x and y are given in pairs. And the variable now, the variable button is going to be t. So you can type in 5t minus 1 or x1 of t. And then y of t is t squared. And then start again with the standard window. Looks like we're not getting the whole thing. The standard window now actually thinks that t is a seems kind of strange, but you're probably going to have to fix that, especially here. -4 to 2. So that would be your t min and max when I was talking about what to use if they don't give you something. That's your t min, your t max. And I would use a t step of 0.2, or sorry, 0.1, or 0.01 even. 0.1, yeah, let's use 0.01. Usually algebraic. Alright, so looks like we get part of a parabola. If we're looking at the whole thing, maybe 10 to 10. Probably would be a parabola. It's way off the screen. All right. You can also trace these. If you trace these, it should show you what it's doing as far as various values of t and what x and y are. And that's why we won't see it for a while. X and y are -50, probably 90. And it's going at some smaller increments. Let's see, if I did it at 0.1 instead of 0.01, it might be just as good and a lot faster. All right, now by hand, what's going on is, or how you would do this by hand and what your calculator is doing very fast, is it's taking these values of t from the min to the max, calculating x, and calculating y, and then plotting that point and connecting the dots in order. So to do this, by hand or just to see what's going on, we could plug in these numbers from -4 to 2, picking integers that are easy to calculate. Plug each one in for t here. 5 times negative 4 is negative 20, minus 1, negative 21. 5 times negative 3, negative 15, negative 16. 5 times negative 2, negative 10, negative 11. 5 times negative 1, negative 5, minus 6, 0, negative 1. You can see that this is a linear pattern, isn't it? What's the next one going to be? They go up by 5 every time, don't they? That's the slope. That's the change in x for every increment in t. And 9. Whereas y is what makes it a quadratic. Y is t squared. 16, 9, 4, 1, 0, 1, 4. All right, I need lines. Not do this. All right, so plotting these points, I'm going to skip that first one. Negative 16, positive 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Negative 16 is way out here. Positive 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Be about there. Actually, since they gave me a specific interval, I really should show the whole thing. 17, 18, 19, 20, 21. Just get a little cluttered. And then up here at 16, 10, 11, 12, 13, 14, 15, 16. Because that's like an endpoint, right? Because they said use this interval. So it actually starts there. And then it comes to this point. That's negative 16. And then negative 11, 14, 13, 12, 11, positive 4, 4, negative 6, 2, 4, 6, positive 1, negative 1, 0, x intercept. You just got to ignore the t when you're doing this, that's the hard part. 4, 1. And 9, 4. You want this piece of that parabola. Looks like that's the vertex right there, doesn't it? Oops, stop. Yeah, when they give you a specific interval, you stop at the endpoints of that interval. This goes below the axis, sorry about that. All right, so which one? Oh, look, they even tell you what to use for the window. And you can blow that up and see, but yep, that's the one. All right, then they want you to get the equivalent rectangular equation. Now to do this, there's some options. In this case where it's algebraic, trig functions, you can solve one of the equations for t and then substitute it in to the other equation. Like that first equation, you wouldn't want to solve the second equation for t because then you have the plus or minus square root. But if you solve x equals 5t minus 1 for t, 5t is x plus 1, divide by 5, and then plug that in for t in the y equation, x plus 1 over 5. And presumably they want you to simplify that. The 5 squared, which is 25, x plus 1, quantity squared. That might be good enough. Let's see. Otherwise, you have to FOIL it out, but should be. Let's see. X plus 1 quantity squared all over divided by 55. And there you can see it's a parabola, it's quadratic. Very wide. That 1 over 25 number is a stretch, or not, compression. Squeeze. All right. Number 2. Similar kind of thing. X is now the square root of t. Y is 3t minus 5. Put that one in and see what it looks like. t in 0, 4. So if you go to your window, change it to just from 0 to 4. Oops. So enter 4. And yeah, 0.1. Hopefully you're good enough. Did they tell us what window to use? No, but it looks like those are all minus 10 to 10. So which one?
C.
Ooh, B and C are very similar.
C.
This one just goes a little further.
Yeah.
So let's trace this and see where it ends. Or you could plug in that last value t to see how far it goes.
It's B.
Yeah, that last value t is 4, right? That's at the point 2.7. So, blow this up. Oh, it's like B. Because the other one, this one goes up to 10. So that's it. Going up to 7. 2, 7, yep. Okay, but again, that's what you get if you plug in 4, right? So you could plug in the endpoints, without having to do a whole table and get all the points. You could plug in the endpoint 6 to see where it starts, right? It starts when t is 0, 0, -5, and it ends when t is 4, 2, 7. You can just plug in those endpoints. Let your calculator do the rest. The rectangular equation for this one. Let's see. X is the square root of t, and y is 3t minus 5. So this one would be the easiest to solve for.
I've used the way you can just square each side.
Square both sides? That'll work. Good job. 3x squared. Excellent. All right, x is t cubed plus 1, and y is t cubed minus 5. For t is minus infinity to infinity, so now we want the whole thing. So t cubed plus 1 and t cubed minus 5. Is it? Yeah, this one, yep. Oh, and change the window to minus 10 to 10. The whole thing. And yeah, it looks pretty linear. How come?
Because you solve for the equation.
Yeah, if you solve for t, you're going to get something with the cube root, and then you plug it in and cube it. So actually an easier way to do it is just to realize, well, hey, if I just solve for t cubed, I can plug that in for t cubed. So y is x minus 1 minus 5, which is x minus 6. I mean, otherwise you'll have a cube root, you'll cube it, it'll go away anyway. So sure enough, it's linear, it's b. And there it is. All right, number 4 involves some trig. So here they give t as an angle. X is for cosine of t, and y is for make sure you're in radians and go with the standard window. Oh, the dangers of typing over. Left here. That one hurt. And stand up. C. Is that circle? Oh, we didn't even need to graph it. Okay, so they just want you to convert. In this case, solving for t doesn't really help. So what you want to do instead is solve for the trig functions. Cosine of t is x over 4. And sine of t is y over 4. And then use a relationship, one of your trig identities, that will relate sine and cosine. We don't want to go with r. This is completely different. Yeah, we don't need, yep, no, that won't. Yeah, this is not, yep, no. It's very different. So what we want is an equation that relates x and y. We want to put these together somehow. Okay, it's not a replacing, it's putting them together really. So, you know, it works sometimes to do this, you know, solving one of them for something to substitute into the other. Here what we need is just...
Would it be like the cosine x over 2, cosine,
Nope.
inverse cosine?
Nope, nope, that's not going to help. Nope. Nope. Give me a relationship between cosine and sine, an equation that tells me how they're related.
Cosine squared plus sine squared is 1.
Bingo. Cosine squared plus sine squared. So, what's cosine squared?
X squared over 16.
Okay. What's sine squared?
Y squared over 16.
And that's done, although it'd be nicer to multiply both sides by 16, right? X squared plus y squared equals 16. Should see more of it. Sure enough, it's a circle, centered at the origin with radius 4. That one. See, the rest of them can't be, because they're not rectangular equations. A rectangular equation has just x and y. So if it's got a t or a theta or a, something else, that's not right.
And you graphed them as a circle and stuff.
Right. Yeah, you could do it that way too. All right, up there's the graph. I wanted you to do that after you figured out the equation. Okay. Number 5, back to algebraic. For all t, x is 3t and y is the square root of t squared plus 5. So what does that look like? Yeah, the parametric and polar are very different ways of graphing, just like the rectangulars are very, these are 3 completely different ways of looking at graphing. I need to adjust my max on t. Yeah, 0.1 is what I was thinking of, because that's similar to what they use for readings. It looks like another kind of parabolic type of shape. Egg. Nice wide parabola. And what's the rectangular equation this time? Well, x is just 3t. So yeah, x over 3 is t. Might be a good approach. Y is the square root of t squared plus 5. Short-term memory loss. So plug that in for t. So 3 squared. X squared over 9 plus 5 and yeah, unless you want to get a common denominator. You could, that would be x squared plus 45 all over 9. And then you can take the square root of 9. Yeah, it's a little nicer, but it should accept either one. Let me try the first one. Square root x squared. Oh, no parenthesis needed. X squared. It'll stay inside the radical, right? Until you arrow out over 9. Arrow out of that fraction plus 5. Yeah. These new windows are so nice, aren't they? Have you noticed? You didn't used to be able to see. It's way brighter, and you can actually see out of them. They used to be just kind of white. It's interesting. From here. All right, so that's that one. Number 6 is real similar. It's a rectangular equation. Number 7 is another cosine sine. You can see almost right off the bat that that one's going to be a circle, radius 7. That one. Number 8. This one is a little bit different. This is leading to what we're going to be doing after Thanksgiving. It's a squish circle, and you can tell because you got different coefficients. It's going to go 9 units in the y direction and 8 units in this direction. So it's actually slightly elliptical. 8 in the x direction. 8 cosine t.
It's 8 in the y.
8. Oh, that's what. Oh. Well, we don't know. There you go. This. Okay. We better make sure. 9. Because they've got sine with the x. And you've got cosine with the y. You're right. So yeah, really y should go up to 8. X should go up to 0. Yeah. So you could trace, and you should be able to calculate a value once it stops counting. Goes around 4 times. Oh wow, you can do derivatives. Calculate a value for t equal to radians. Pi gives you that point down there. X is 0 because it's 9 sine of pi, and y is -8 because it's 8 cosine of pi. Whereas if you put in maybe 0, the 0 angle, well, then you get that one up there. What about pi over 2? Yeah, I can put that in 0. Or you can just trace. So it is. All right. Any questions? So, how you doing on the homework so far? Should I look? I haven't looked since I last nagged you. It's a lot of stuff to learn, and you have to spend time with it. So that's